portfolio, and also transaction and extrinsic history, which is something people have been asking for a long time on the extension. So that should update automatically for people. And the iOS wallet is our current push right now. So in the next month or so, the iOS wallet will be dTAO, which is really exciting. But anyways, yeah. So to the people that were confused about the couple days when they couldn't stake, uh, that's now over, and you can use the extension um, to interact with dTAO. Great. Okay, so we it was a smooth launch. On the face of it, behind the scenes, we're putting out some bugs, and there were some updates on the chain from the subtensor nucleus team that were important for people to know about. So there was an excessive alpha dividend issue over the first 5 days of dTAO. So APRs were too high. So that's been fixed now. There was also an issue with subnet owner deregistration. Some people were getting deregistered, even though they're owner of a subnet. So right now, we fixed that so that the subnet owner cannot be deregistered. And also, there was a bit of a backdoor there where they could register a whole bunch of hotkeys. So we've stopped that from happening. And then there was also some small stake overflow issues based on the lazy accounting methods that we were using. So some people lost a little bit of tau, and so OTF is just refunding the 9 tau that was lost via that. It happened specifically on Ari's validator as a consequence of him having not much stake, and then there was some overflow operations. So that we fixed that. That won't happen anymore. In fact, we just don't allow you to stake if that is going to occur. So sometimes a stake operation will just not go through, and that's because you're not staking enough, or there's not enough stake on the validator for that operation. So these are the updates from Nucleus over the last week, and next week we have some big ones coming out regarding potentially new liquidity pool management, but I'm not going to talk about that right now. bittensor 9.0.1 went out, and there was some small fixes for BTCLI, but also features. So get and set identity for subnet owners. This is something that I recommend subnet owners do to override the default identity that is on the chain. And if you set this identity, it actually shows up on tau stats. And also in the BTCLI. So when people are doing BTCLI S lists, when they're viewing the subnets, you can actually have your identity there automatically on the chain. We've brought back BTC Stake List Live. It's quite a fun thing to watch. So you can watch your stake live for the BTCLI. And there was some subtensor interfaces making operations faster for people that are building MEV scripts and stuff like this. We got some feedback and improved the SDK. 9.0.2 even went out this week. So we have list stakes now includes tau emissions. We've improved the wallet balance function so you can see your stakes with slippage. You can also do -- all on remove stakes, and it's much easier to set hyperparameters. For instance, a lot of people were calling for pseudo set toggle transfer. If your subnet has some issues there with transfers, you can change that now via the BTCLI easily without going to Polka.js. Cool. So I don't want to take up too much time from Macrocosmos' guy's presentation, but I thought there was a couple things that were really interesting about the first week, which I think was a major success. The first one was just massive amount of volume. A lot of people were playing around, and that amount that people were injecting into the subnets really increased over the week. We saw 147,000 tau allocated into bittensor, roughly $59 million worth of movement on the chain. And this is honestly peanuts to where we're going to go, but it's a great first week. And we matched 10% of the volume of tau itself just in that same period. So this is something that OTF is going to be focusing on myopically, about making bittensor the first class place for interacting with subnets. We want to capture that market on chain. And really be and do that by increasing the ability for people to inject liquidity into pools and build better tools for really the best place for AI DeFi. Interesting result, I think, was that root network actually wasn't that bad. For some people, it was fantastic. Other people, it was terrible, and there has been some jostling around in the emission vector. that's fantastic. I'm really happy to see that, but also it wasn't all that bad. So some of the top subnets on BitTensor stayed at the top, and I think that means that validators, we did a decently okay job. Pat yourself on the back, but ultimately, really, we needed dynamics so that we can scale, and there were some issues with that ranking, and it showed up in the first week of dynamic. So I'm really excited to see how this plays out. And every time I do one of these updates, I will come back to this slide and see how well we've done. Okay, there was a conversation in the RAW channel about the slowness of the EMA. So we also did a mathematical analysis of the EMA and what value we think is reasonable going forward. We wanted to pick a really slow EMA to start, just to reduce the chaos of the rollout. And there was a lot of chaos initially because of the low liquidity. We wanted to pick a really slow value, something that we could increase later, and we are going to do that. So when we're talking about the EMA, the thing that we need to measure is the edge that, or the tau prize that someone could get by manipulating the emission vector. And we can measure how effective this kind of attack can be by looking at how long it would take for, how long would an attacker need to wait before, and by attacker, I mean somebody that attempts to manipulate the price in the short term. How long would they have to wait before they can actually make a gain when no one else is attempting to basically pull out those gains before them? And so the time it takes for this attack is very important. And we picked 3e-6, which meant it took about 92 days with root divs. Now, as the markets become more efficient, it becomes a lot more difficult, especially when there's more liquidity. And so we can easily move the EMA factor to move faster and faster, and therefore rank subnets much faster and do a better job from the chain side in adding liquidity where it's most needed. So we think that we can do this now. Our analysis shows that an attacker would need about 64 days with 3e-4 EMA. That's much faster. And as you can see from this graph here on the next slide, this would be the difference between those two EMAs, where 3e-4 is 100 times faster than current EMA, but still gives us a fair amount of protection against this attack. Now, I want to say that we are going to be focusing on updating and improving the emission design on BitTensor for a very long time. I think it's super important for the BitTensor chain to stimulate the right types of projects. And so I think that this is something that is a lot of design and mathematical work is going to go into figuring out how we can perfect not just the EMA, but even future designs in BitTensor for how we determine the emission vector. Right. So yeah, that's it really. Without further ado, why don't we jump to Macrocosmos? I don't want to steal their show. Yeah, guys, let's go in. Let's talk Macrocosmos.
Let's go. Thanks, Jake. I'm gonna share my screen. Can everyone see? Does the screen look like the right size? Everything all good?
I see yeses in the chat. Good
sign. Is it tiny? It kind of looks tiny on my screen. Does it look like the normal size? It's tiny.
It is tiny. It's oddly small.
Let me just... What about now? Wait. 3 inches still big. There you go. Okay. Let me try reload this. Sorry, guys. I'm gonna put that on there. Any bigger?
It's bigger.
It's bigger. That's what we want. Well, guys, seems there's been a lot going on in BitTensor. I think the last time we came on Novelty Search was September, when some of the distributed training and decentralized training results that Jake announced and otherwise sort of started the first run. So we're hoping that this event has a similar effect. But look, we kind of cut this down to keep it a little bit shorter than we planned to. We've got an infinite amount of stuff we'd love to talk about, but people probably want to ape and talk about dTAO again. So we're going to run for about 20, 25 minutes. But Jake, if you want to stop or ask any questions or other things, then we've got loads of time for questions at the end. So I guess a bit of a reminder for those who don't know who we are. We're 34 people. We're based out of primarily the UK and Western Europe. And we were one of BitTensor's first teams. Stefan and a lot of our core team joined from the foundation. And we really set out to try prove that BitTensor can not just participate in the creation of AI, but try to actually lead the creation of open source AI. And a lot of our vision for this has been that BitTensor can do more than just individual subnets doing clever things and be something more than the sum of its parts. We operate 5 subnets, which I think sometimes I regret, sometimes I'm very excited about. But we're going to talk to you a little bit more about a couple of those flagships and everything we've been working on, and give you some new news. So Steph, I don't know if you want to add anything, but
I think the big story here, guys, is it's a real moment of reckoning for us all. dTAO is live. It was an amazing launch. Congrats to Cons, to the foundation, and we've entered a new chapter together. And it's a great moment for us to really focus on our objectives as a community. I think the temptation is strong to follow the instinct of the rest of crypto, and you know, there's some risk that we descend into meme coin madness. I think that we have a lot of really great teams in BitTensor that are actually building what I would consider to be, you know, on the brink of breakthrough technologies. And it's really a moment for us to be busy building and not too worried about what's going on with all of these extra layers around us. So let's keep it moving, and we can introduce a little bit more about what we're going to talk about.
yeah, so perhaps one note here is we only have one benchmark in the deck. We've been renowned as the benchmark team. If you want a few more benchmarks, we've probably got some in the backup, but today's a day about talking about products. So before I think last week with dTAO, we posted this sort of vision of a few different futures for BitTensor. And one of those is this idea of like a supernova, that we burn really brightly as a protocol, and we have some big results and we do some crazy stuff, but we never really solve the big problems, the big challenges in AI. We don't solve this thing of how do you combine not just compute, but intelligence and data and human capital to ultimately not just compete, but beat centralized AI. And so a big thing for us is BitTensor needs to be more than the sum of its parts. And like, we think that this community is the best community in AI. And we think subnets pulling together can do something very, very, very powerful that can do some crazy, crazy, crazy things. So we're going to talk a little bit more about that today. We operate 5 subnets. And the first 2 we're going to talk about and launch product on today are Data Universe and Apex. So there's been a lot of noise about that. We're excited, but let's see. Data Universe is data scraping. Apex is our enhanced agentic intelligence system. And our training subnets are building the best models on BitTensor.
As Will and I have said, I think on a number of occasions, when you use the blockchain, you get to tap into a really large reservoir of potential if you can coordinate it. If you can get people to actually point in roughly the same direction, you get an enormous amplification. And what this turns into, if you have the incentives right, is we can actually be the project that produces the biggest data sets in the world. We can build the best agentic assistants in the world, train the best models in the world, and also tackle big picture problems that go beyond AI as well. And that's really the thread that I think connects what Will and I want to share today. We're not going to have time to get through all 4 subnets. We're going to mostly focus on the 2 that we're going to be sharing product with you guys today on the call. But really the thread that connects all of this is sort of, I feel like we made promises at the start when we joined BitTensor, and our ambitions are very high. And we're very proud of where we've gotten, and we want to show you guys where we are today.
So let's go. Data Universe. Data Universe was my big conviction moment for BitTensor when it just started inhaling more and more data than we'd ever seen. Now, today, Data Universe has downloaded and scraped over 34 billion rows of data, which is 100 times more than the next biggest data subnet on bittensor. It's just kind of insane. The miners just do things that we believed were impossible, and they do a lot. At this point, we're basically indexing all of social media, which is kind of nuts. And we didn't really understand how they do it. We still don't understand how they do it. Vlad, our lead on 13, is from another universe, a data universe. But we sort of looked at this, and one of the litmus points on Gravity was when we tried to predict the US elections using it in November of last year. And what's important here is it accurately predicted the election, but what it actually predicted was the sentiment of the election of the public. These numbers almost exactly mirror the betting figures on Polymarket for the US election, which is interesting because you start to see there's real value in this signal, and it can be really, really powerful. And we sort of looked at that and said, right, we need to build something on top of it. So with Data Universe, we're going to give people unstoppable analytics, access to web-scale data sets, and access to a streaming API that can do really, really fantastic things. But the best thing to do is kind of show you guys. So look, this is Constellation, our unified subnet platform. There's a few things that aren't live here. We're going to be talking about that more, but let's enter the Data Universe. I scraped a few things earlier today to provide an example of this. This is something we're working on with DraftKings. There's over 10 million rows of data you can't see. I'm showing the wrong screen. Give me a moment, apparently.
Yeah, really, we can just see your browser with Data Universe gives off.
Huh? Okay, let me like refresh the screen. Apparently this doesn't work. Stop stream. Give me a sec. Aha, I think I've solved this now. I'm gonna go back. I've lost my moment now. Reloading. Can you see? Cool, somebody shouted yes from the other room. So this is Constellation, our platform. We're in, yeah, it's exciting. And this is the Data Universe. Now, this is very much an MVP, guys. It's at a sort of bare bones level. And we're gonna release this to everyone today at the end of the call. So please break it, tear it apart, destroy it. Fish, I'm sure you can do something that we didn't think possible, but find some way to make this thing break. We've done a bit of rate limiting, but for the next few weeks, we're going to let everyone just have a go at this while we scale it. But we did a few example scrapes of this, and this is an example of scraping sports tags and Reddit tags. There's something like 5 million data sets we can pull in a matter of minutes. This thing is really, really crazy. When you look at crypto data sets, you can pull a shed load of data. And I've built a data set, for example. Here's 22,000 rows of the hashtag #TAO in Twitter that you can go dig and pull and use to train your agent and use to do whatever the hell you want. Like, this thing will just inhale everything. That's what's really cool about it. Similarly, we've looked at brands and other topics. And Jake, maybe you want to, do you want to scrape some data, Jake? What sort of data do you want to scrape?
dTAO?
I mean, we scrape dTAO, but we can have a look. So dTAO, I don't know if there's any dTAO data sets out there on Twitter. We're the thing is that currently the segmentation's mostly through hashtags, and we're building out, wait, somebody said stop, what's happening? Do I need to like, I've got Mog just having someone tell him this. Cool, you can see.
We can see.
Let's scrape bittensor, let's scrape Coinbase, let's scrape Wall Street Bets, let's scrape, I don't know.
Render.
You can pull that.
Let's do some crypto AI stuff.
NEAR, ICP, other crypto.
Virtuals.
Yeah, let's scrape virtuals and let's see that. And let's just launch that. We'll come back to that.
What's that?
Libra as well. Meme coins, Libra.
We've missed Libra, we've done that. This is going to cook for a minute. This is currently dispatching desirabilities to the chain, connecting to subnet 13, and we're launching scrapers that are basically going to crawl the existing data set the miners have and start to build a data. So we'll go ahead, Steph.
So yeah, I guess speaking a little bit about what's happening in subnet 13 here, You can think of it as like a listings board that the miners can constantly view. And as soon as we post new labels, they're basically funded using the validator bandwidth. So that's going to be the way that we're going to build a pricing model on top of this. Right now, this is free to access, as Will mentioned, but ultimately, the amount of data that you want is something that we're going to be pricing into the model here. We're going to tell you a little bit more about that when we get back to the deck. But really, this is baked in at the level of the incentive mechanism.
Guys, self-streaming in 22,000 TAO, 14,000 ICP, 4,000 near. What's coming next?
So this is all real time.
This is real time. This isn't streaming directly.
This is actually a blend. So there's a blend of the historic data that's been scraped into our big monolithic data set, as well as real-time data collection that's happening on top. Of course, right now, there haven't been 22,000 posts in the last few minutes. So what will happen is, to begin with, right now, this is going to be picking up a lot of the historics, and it will also start to pick up everything live as well as the miners start to exhaust what's out there, because they're just hungry for incentive. And what we're going to
the miners pick this up in real time is what I'm asking.
The miners are picking this up in real time, yes. So another thing that we're going to add to this as well is a time range. So you can be much more specific about the date range that you care about. I only care about posts in the last 5 minutes, for example. And what you're going to see is, as a user, you can select that, you can configure that. It's going to feel like a very configurable way to get the data the way you want it.
Oh, 6,000 rows on render, guys. Maybe you should be buying sell your near for render. Ooh, 660,000 on Wall Street Bets, one on the Reddit bittensor.
So take me through how this happens. So you went to this front end, you typed this in, it posted to the validators. The validators attached this to some database. The miners picked it up instantly and then went and started scraping 661,000.
When I refer to the miners picking up the historic records, what is actually happening here is the miners have already uploaded to Hugging Face very large data sets, and they continue to stream their posts into those data sets. They're uploading new posts. So what we're doing is we're constantly taking snapshots of this sharded data set that the miners maintain collectively on the back end. So if I was to choose something that has not been scraped before, an entirely new label, which we can look at in all those Hugging Face data sets and see that nothing is in there, that would be a perfect example about the completely on-demand component. This is a blend of on-demand data scraping happening right now, as well as historics, because we have not filtered by time. That's going to come. This is an MVP. That's going to come in the next version when you can actually customize. I only want the streamed stuff right now, or if I just want big volume data delivered to me in the last 30-day range, for example. So this is a 30-day range lookup.
There's also a direct streaming API, so you can stream real time from Twitter. It got slightly broken in detail. We're shipping a fix tomorrow, but this will go as part of an SDK and dev toolkit. So you can get minute by minute, second by second live posts if you want, or you can get these large volume pulls as well. And when other platforms are talking about pricing in 30 cents for 1,000 rows, we're talking about pricing by the million rows.
Wow.
So,
and
a big question.
What is the normal pricing for the amount of data that we just saw on the screen here?
So typically pricing from the likes of Twitter, if you want to pull 1 million rows through the Reddit Pro API, the Twitter Pro API, it costs you $5,000 a month. So you can see here, there's about 1 million rows here. What's powerful about Gravity is we have Twitter, we have Reddit. We're going to be able to have Discord, Imgur, anything you want. And the point of this is like one place, one price, all the data. We're centralizing all the other participants to centralized data scraping.
Holy shit.
You want to go back? Stefan, let's go back to the deck. Give me a moment.
We're going to run out of time. We've got more demo.
This is it. No internet.
What happens if you click build data set?
So if you click build dataset, basically we launch a crawler into the back end that goes across all of the different miners data sets, pulls all of these things and builds it into the back end and starts to pull this together. It takes a couple minutes to run with the current orchestration. We're going to be accelerating this. We've been scaling some of these components. But basically, when we come back to this in a couple minutes after demo 2, you're going to understand a little bit more. So let's move on, because, we didn't come here after a few months just to show you one product. We can come back and we can look at your render data set in a minute, Jake, and see how it's maybe not quite as good as your TAO data set. So let's go in and say, the big thing to ask yourself as a data scientist is I've got these millions of data. What do I do with all that data? So you have gravity, you can pull the forces of the universe together. Enter nebula.
So what we've done is we've vectorized the data sets that we scrape in subnet 13. And what you can see here is a low dimensional embedding of the sentiment of all of those posts. This is actually built using all of Discord's public posts. And I use Discord as a fun example, but any data you will be able to scrape, you will also be able to visualize and analyze in a way that I'm going to describe right now. Discord is kind of a fun community topic to go into. What you can see right here is every channel that is publicly available in bittensor right here. And this is really something to behold, guys. I mean, I think, Const, you've said a few times, bittensor is building a brain. I look at this and I see that these are the brains that are building bittensor. So this is every conversation that's basically happening in every subnet. We can monitor sentiment of it. We can monitor volume over time. We can filter by date ranges. We can filter by authors in this demo right here. We're going to give everyone access to this at the end as well. If we share the link right now, no one's going to pay attention. So we're going to just curate this a little bit right now, and then you guys need to play and break things soon. So let's say...
Why don't we find out Jacob's mood throughout the last few months? So let's talk about Const. Man, you did not enjoy June. You did not enjoy June. Let's go look at some of the comments.
I lost 67. I lost $25 million in June from a hack.
That is literally the hack, isn't it? Shit.
Well, one thing that is very clear is Jake is everywhere in Discord. It is a legend, and it is proven with the data, guys. So again, this is intended to be a way to interact with your data, better understand what's going on inside of your data. This is going to be something that you'll be able to soon. We're actually building a natural language interface so that you can just talk to this data set, and it will basically filter it. It will interact with it in the way that you want. We're training a series of models right now that are actually going to enable us to do that. We're really excited to push that level into bittensor as well, so that we can build these models that enable you to query vector databases in real time. But really, the main thing we want to share is this is going to be going live in our Constellation product. Anyone that scrapes data can just build these nebulas on top of their data sets. We'll make it possible so that you can share them with each other. You can do analysis, build reports on top of them. So this is really a journalism tool. It's a market analysis tool. And I'm gonna leave it there because we've got a lot of slides to get through. Really, really excited about this. It came out really well.
Yeah, and guys, this isn't performing enough, so it might take a minute to load. There's a reason we haven't scaled all of this, but we've been cooking on this for a while, and it's great fun. And you know, you can, like, I use it to track which of my team members aren't shit posting now. So like, I can literally get who's working hard and who's not. So it's a management tool as well as anything else, guys. But let's move on. So we've seen gravity, we've seen nebula. We're going to let you guys play with it later. Let's talk about Apex. Let's talk about Subnet 1. I'm going to hand over to Stefan to lead this section, but let's go.
Yeah, I think, guys, bringing us back to what we said at the beginning about the potential of bittensor to do things that are not just derivative from what the state of the art gives us. We live in a great moment. The state of the art is catching up and it's starting to win. That kind of came faster than I expected. I thought it was 6 months away, and it turns out it wasn't. Great news for all of us. Great news for bittensor. But the thing that I really care about, and one of the main things that we are focused on in Macrocosmos, is finding out ways to push past what we can just take off the shelf from Hugging Face, and how can we start creating more native intelligence within bittensor. So I guess to summarize what I just said here, open source is catching up to closed source. News. Really good for all of us, really great for the story of what we're building together. But bittensor should lead in the open source movement, not just use it. And what this means is really we're going to always get lifted by the tides that go up and down from the world around us. But how do we actually move all this? And this is actually a sort of modified plot from an NVIDIA blog recently. Jensen was talking about 3 scaling laws, and I'll try and keep this at a pretty general level. The main idea is there's different ways to get more out of deep learning. One is you pre-train it for more compute, bigger data sets. You can do clever things like using different data sets and schedulers and all. The main thing is the more compute you throw at training the model, the better the model gets. The second part is called post-training. That's taking this model, which is just a compressed representation of all of the internet, and actually getting it to role play, to be a useful assistant, to follow instructions, which is sort of the GPT that we've learned and become very accustomed to. The third component of this is much newer. It's the idea of letting a trained model think for longer to produce a higher quality response. And this has always been our North Star in Subnet 1. We've explored exhaustively, well, not quite exhaustively, but we've explored extensively all the different ways that we think that this is incentive. And, you know, we've tried some things, they didn't work out so well. Shout out hard year for Subnet 1. But we think we've got something now that is worth talking about. And it's taken us a while to share this with you guys. It's a strange beast because it's very different to the kind of service that you get when you use models off the shelf, because it's inherently higher entropy. It's a little bit unpredictable. It's surprising. And for this reason, to be honest, it's hard to demo live, but we're going to do it anyway. So I guess, look, moving on, the components of Subnet 1 as they stand today, and very much just, this is the stupidest version of Subnet 1 that you guys are ever going to see. We're working very hard on adding more and more incentive layers to push test time compute. But right now, we recognize that it was important to have inference. Inference is a bedrock. It allows us to do things that are predictable, make sure that there's not too many jelly bricks when we're building the house. Inference is basically just reliable, high throughput tokens from state-of-the-art open source models. Right now, we use Llama 3.27, but we could switch that with just a click of a button to R1 or whatever comes next. That's not really the measure that we're worried about. It's about the margin of improvement we can get past any reference model that we can take from Hugging Face or similar. Another thing that's important that we've integrated into Subnet 1 is the ability to search the web live. Of course, this means that it's not limited by the data trained on, but it can inform itself about the state of the world in real time by querying the web. Another thing that we're working on right now that's not in the MVP, but this is becoming tools. So a sophisticated agentic assistant can also use tools. It can execute code, it can run experiments, it can also call APIs, whether it's going to get the weather or it's... And we are looking at ways of bringing all of that into bittensor as well. And lastly, something that I've talked about a couple of times is the ability to reason. So test time compute is basically, the more tokens the LLM can think for, there's a general trend of improvement towards the quality of the answer. It catches mistakes, it can go on, and it's basically, it has more time to think and to run its computational logical. So in the version of Apex that we're going to be releasing today, we've got basic, which is just inference off the shelf, Llama 70B. That will be supporting extra models as well soon, but we think for the use case that we care about right now, we just need one suitably powerful basic model. We've got web enhanced, we've got chain of thought. So chain of thought is something that's actually a composite task built up from inference tasks, but it makes it easier for users to get better quality results in a very predictable way. Would be the way that I would describe it. So what it actually is it's a string of inference requests that go to miners back to back to back to back with a very carefully curated prompt, so that they are told to, be very fastidious, be very pay a lot of attention to detail. And so the result is it's going to chunk out block after block of output. And again, the goal here is to give users a sort of a one-click experience to get beyond what is possible by just running a base model with a generic. Apex combined is a mixture model. What this means is the user's request is sent to multiple miners, and we enforce those miners to run different models. So you can think of different seeds, different stuff like that. The point there is you've got some diversity now, but because they're built from this basic model, so combine is also deterministic, except the seeds that we switch in real time. But the point is you sample from a much larger pool, and you can basically benefit from the wisdom of the crowd. So you get multiple responses, and then we run another step. And what this is going to do is it's going to gather together those responses and come up with the best response by taking sort of a majority vote. So the UI for this is still very basic right now, but we think it's important to just start sharing this stuff soon. And the last one I'll cover is our reasoning endpoint. Something very exciting. It's, again, quite high entropy, but the idea here is that the miners are trying to catch up to the validator. So once in a while, very rarely, the validator produces a reference answer. And this reference answer is produced using many, many, many tokens, okay, thousands of tokens. But the miner has a tiny fraction of the time to do it. So you've got this asymmetry in time, which makes for a challenge. Miners have to get creative. They have to figure out, how can I get as good as something that took 5 minutes in 5 seconds. And that kind of asymmetry is something that we can leverage with organic. It's not about synthetics anymore. This is all organic. Yeah, did you want to jump in on that?
I think the point here is we're building a kit of tools that we can combine more and more intelligent tasks within Bit. And the vision here is really to move towards a bittensor native deep research that allows miners to bring their best in, not just in running infrastructure or GPU optimization or some of these other pieces, but also actually in combining better outputs. And we've seen some really cool things with this. I think we're just going to move on and probably show you the demo now. So,
all right,
let's play.
God help me, everybody. This is really a moment of reckoning for our miners, for us. They are not ready to start getting share there. So let's go into Apex. We'll do a web retrieval task right now, which is using the web, and I'm going to ask it a question that I know it can't answer just based on training data, something that is relies on real world time. So let's ask, what is the best Indian restaurant in the south of Paris that is open late on Tuesday? So we'll send that out. So what it's done right now is it's searching the web. Again, the UI is going to be polished much more. This is very much key. Now what it's done is it's found sources on the web. It's integrated those into it. It's tandoori nights. Dhaba apparently is a great place to eat dinner. And what you can see here is basically it now searched the web. It's integrated that into its response. So that's pretty cool. Let's try something else. Let's try the reasoning task. In the interest of time, I'll leave it as an exercise to the reader for you to play with this afterwards. So let's ask this a question. How long would it take for a snail to cross an airplane hangar? So a little bit tricky. I don't know if Llama could do this out of the box. That was fast. That was suspiciously fast. Let's run another one. Jake, have you got a question? Give me a reasoning question.
Write a Uniswap v3 pool in Rust.
Uniswap v3 pool. What was the end of it?
A pool in Rust.
In Rust. All right, let's go. My heart.
So the reference
Wow.
answer, the golden truth, right, is generated by the validator by doing like thousands and thousands and thousands and thousands of tokens.
Yes.
That's how you get this, right? So basically you're using the asymmetry between time and intelligence. You're going, well, we can run a small model or even a reasonably large model for a very, very long time to get the best reference answer. And then they should be able to get this in a second.
Exactly. And the responses here are super fast. We actually internally this time dilation inference, which we thought was kind of cool.
Yeah. Look, we survived the live demo. I'm on with the presentation.
Do you want to try chain of thought? Chain of thought like fell over an hour ago. So
let's do it. Your favorite reasoning question. Maybe mine is not that great.
It came up with an answer. Chain of thought.
I think we should quit while we're ahead.
Everyone can try breaking it, try pulling it apart.
You guys, the bug reports are going to come thick and fast.
Have a go of chain of thought. How can my CTO take his 3 children on a backpacking holiday in South America?
How?
I don't know.
That's such a weird question.
It's running a lot.
So yeah, part of the way that this works is because it's back-to-back inference steps, it doesn't stream yet. We actually wait for an entire block to come through at once, which is why it's a little bit janky. We're going to figure out how to make that a much smoother UX. Right now, that was an entire completion from a miner. That's another completion. And the purpose of this is because they're responding to us in a specific format that we need to validate before we accept it front end. But there you go. I'm not...
I think
what am I doing?
Working. You're taking them, you're refining it, educating. I think what we expect here is as we put reasoning models into this process, we can extend them through time and ramp up. So we can broadly bound how long we ask them. We can combine it with the web enhanced task. and we can start to do more and more and deeper thinking within Apex.
I love that it ends with confidence level 9%, remaining uncertainties 10%. That's great. Let's go on to the next subnet.
Wait, but before you go there, Stefan,
Yeah.
can you just talk a little bit more about this asymmetry between time and intelligence? Because I think it's super interesting, and I hope people didn't miss that because it's fascinating.
Sure. Yeah, I'm happy to. So I guess before we tried to do this with time, what we did this a lot with synthetics. So we thought, how can we make a question that a validator can produce from a privileged point of view? It has access to a specific reference material or something like that, and the miner doesn't know what the reference material is about. So the miners have to go and do some kind of web search and then answer on top of that. And that was an asymmetry. The hard thing about that, Const, is that when you have an organic, well, how the hell can the validator, match all of that same asymmetry performance and create a suitably high bar that the miners have to reach towards? And actually, time is, I would argue, it's a much more interesting thing to do. So that gives us a knob that we can tune. It's something that users will also be set, like I'm prepared to wait 3 seconds, 30 seconds. And again, this is all built on the fact that given more time to produce an answer, LLMs generally produce much better answers. So the validator just has so much more time. The miner is at a great disadvantage, and they need to innovate in order to be able to get something that is 30%, 40% better than a baseline approach. And they need to create workflows, and they need to think about whether web search. Right now, the reference answer is just a lot of tokens, but very soon it's going to be a lot of tokens with tool use, with web search. So the reference answer that is created once in every 20, once in every 100 times, a lot of load put on the validators. That reference answer is as close as we can get to like the model answer. And we're thinking about ways of even breaking through that point, but this is really the hard for is it's really hard to match the performance if you have less time in inference world. So does that answer the question well?
Yeah, you can surf the asymmetry to infinity.
Surf? You're good at this. You should be on podcast. Yeah, what he said. You can surf the asymmetry to infinity, guys.
So look,
Yeah.
Let's go on. Conscious, we've got a lot of time, and we can bounce in and some questions at the end. I can see people asking me this. We're going to open this up straight after this call. We actually got Hugging Face rate limit build.
The app broke 3 times this evening.
Yeah,
it's been the most stressful day of my life.
But let's talk about training. So training is really important to bittensor, and Jake, forgive me if I'm incorrect, but I think it was one of the reasons you built this was to train large language models or train AI models on this protocol. And we sort of decided in Q4 of last year to really focus on how we train better models. And there was a debate about going bigger, going wider, but we wanted to focus on building the fundamental mechanisms of how do you pull data in, how do you mix data to make better models. And look, we've had some great results. So Steph, he's going to take us in.
Yeah, so I promise no benchmarks. You're only going to have to endure one benchmark. So we're really proud of the models that we've produced in bittensor so far. I think the approach that we took at the beginning was not quite optimal, I would say. The thesis to begin with was really how do we just take a really, really large web scale data set and long enough surely we reach state of the art. And unfortunately, that's just not true, at least anymore, because the state of the art out there in the big wide world, using all kinds of newer techniques, things like dataset mixing, careful scheduling, stuff like that. So what we've been doing is we've been trying to integrate a lot of those learnings into the design of our training subnet 9, subnet 37. We've produced a generation of models that we're now really happy with. We don't just benchmark them on how they perform complexity loss on the competition. We look at all the standard benchmarks that all of the AI labs around the world use to compare their models right here. We've beaten a number of very strong frontier models now. I believe we just passed Quen 14B on some of the tasks. That I direct the reader to our Substack. We have a lot of posts. We've been very transparent about our wins here, losses too. I believe now our 14B is 58% better than the models produced on the next best subnet in BitTensor. Even though those models are up to 50% larger than ours, there's a real margin, and I think this really speaks to the power of the method that we've found, that the miners are finally sort of working in the right direction. We're not against. It feels like it's going in the same direction now. The next part of that as well is, okay, so narrow LMs, that's really cool, but like how flexible, how broad is the scope of this machine that we've developed? So in addition to having multi-data set blending, which is definitely something that other labs out there in the world use, so you don't just use web scrape data, you also use math data sets and coding data sets and multilingual data sets. These really drive the end performance, the end results of the models that you create. But we've also extended the subnet to enable multiple partitions to happen at once. This is sort of a step towards letting the organics in, opening the floodgates, running training as a service, which we'll talk about as well. And lastly, we're going to be launching multimodal a couple of weeks as well. So we're really excited to really test the limits of the design that we've come up with. Look, where it does not succeed, we are very confident to take this recipe and refine it further and make it even better. And this quarter, we're going to be bringing up our training project. It's going to use all of this backend, which we believe is very competitive. It's not just going to be training models in BitTensor, but it's going to be training state-of-the-art models in BitTensor using BitTensor expertise, which I think is a really exciting prospect.
Yeah, I mean, I think, guys, this is the stuff that Sam and Templar are doing. All of this can fit into their evaluation method. I think Gradients used the 3B from Subnet 9, and they had some fantastic results on that. So we see this as a lot of like fundamental research for training in BitTensor. I'm really excited about it. And we debated doing like UX flows and stuff for the training platform. But yeah, look, the big point for us guys around this, and sort of the summary points and rolling up, we really want to build a constellation of subnets. To train great models, you need great data. To do all of this, you need to have inference and intelligence, synthetic data from 1 as a 37. We're going to start doing more of that with reinforcement learning competition. And what we're also going to be doing is embedding Subnet 1 as the large language to the entirety of this platform. So today, the features you'll see in Constellation are driven by ultimately sort of typical UX frames. We're working a lot in the back, really clever stuff with having a natural language interface to drive not just our own subnets, but hopefully many more, and we'll get onto that. But some of you here are sat here saying, what about protein folding? What about folding? It's kind of on the end. And guys, there was somebody who said the other day that like, what's the point in doing protein folding in BitTensor? Like, protein folding's pointless. And we disagree. And I think Google have proved that by launching an AI yesterday. Like, this is the core point. Like, there's clearly a huge market in protein folding. But we looked at this process as we went through it. Now, folding has been a great adventure on BitTensor. We folded 160,000 protein. We actually had 20% more petaflops than folding at home. One of the first big decentralized compute projects. But as we worked, and I guess we built out a lot of infrastructure on SN, I think is important and generalizable. Doing scientific work on BitTensor, the global job pool we created, the organic framework, folding flow mechanism. But when we were working with some of these institutes like Max Planck and Sussex, they said, well, like, folding's good, but you need to do docking. And like, Steph, maybe you talk a bit about docking, because...
Yeah, I mean, so I think we've explained a little bit about the process of protein folding. This is the way that sort of these large organic molecules, extended structures, find their sort of shape naturally in your body and determines how they interact within your body. But a really, really big market that we're looking to break into here called it's called docking. And docking basically means very small ligand protein. These can be particles that are delivered into your body through drugs. So this is really the molecular dynamics of how people actually do in silico studies of developing the next generation of drugs. And what they look at is, okay, so I know what shape the protein takes. In fact, proteins can take many different shapes, which is another story altogether. But given a protein shape, what you want to know is how would a drug interact with it? Is it gain of function? Is it going to be loss of function? Toxic? And this is actually something that researchers are excited to use. And there's a real emerging trend inside of sort of AI-driven drug discovery to combine protein folding with docking. So this is going to be the next step that we're going to take for the protein folding subnet to show that it's not just sort of an abstract exercise that solve hard problems. That's sort of what we set out to do. Now we want to show that like this is something that people will really be prepared to spend money on and be able to do world-class research subnet. So
I guess look, we took some of the criticism to heart, guys. Protein folding, it's a big market, it's 2.6 billion, but I think that's less than Shoots was 2 days ago. So it's kind of a bit lame. You know, it's not even bit scale. So we looked a bit bigger and we said, what about if we looked at scientific research? Now, scientific research, that's a big number, 8 billion. And, you know, one of the things we always sort of dreamt about with protein folding was that we'd be able to do bigger science problems, fusion, other problems than that. So as of today, folding is no more. And we introduce mainframe.
What?
Protein folding is now scaling to generalizable compute subnet. We're going to be talking about more of that in the future. Our immediate research problems are still around drug discovery and docking, but we're also going to be using all these tools to look at a broader range of scientific research problems over the course of the subnet's life. So this subnet 25 still continues to be the heart, essentially, tensor. We love it. It's not going away. But we're going to be doing some really, really fun stuff. And yes, we thought mainframe was a nice tongue-in-cheek name for it.
So you're moving away from just pure folding, docking, protein folding stuff, and you're actually doing general computation?
I think the reality is actually what's happening on the protein folding subnet today is directed scientific computing. So we can get miners to do molecular dynamics, fusion simulation, all manner of tasks within the framework we've built. We're not going to be focusing on fusion in the next 2 weeks, but longer term, we're going to be creating a space to do lots of diverse research problems on bittensor. And we're really open to working with other teams on this. We think it's exciting, but we didn't want to bound. Look, when we were looking at this and saying we're not just folding anymore, we're docking, and we thought about coming back here in 3 months after we changed it from folding to docking and renaming it, and we felt we were best to just plan for the future on this one. So this would be the sort of path to an AI co-science on bittensor. We're excited for it, and we'll be sharing more about that in the coming months.
So, as Will was saying at the start of the presentation, I think a big dream for us is figure out how bittensor can be more than just some of its parts. Looking at the TAO prices, it looks like the subnets are more than the sum of bittensor, which was kind of a surprising revelation. But the idea behind Constellation and hammering home, we want to really push for connecting subnets together so that we really can reach the stretch goal as a community, which is like we have all of the pieces that we need, sort of multimodal AI supercomputer. And we need to start really formalizing the way that we think about how do these things flow from one subnet to another. A lot of different initiatives are coming right now. We have Constellation, which we think is going to be a really big contribution to that space. Of course, for us, to begin with, it's about connecting the various parts of the AI production cycle. So data collection, data training, of course, fine-tuning, multimodal training competitions as well, and of course, agentic workflows and inference. And so what we're really excited about here is bringing Constellation out, giving everyone an access to start working with us on our platform and be part of the Constellation.
So we've been talking to the likes of BitMind, AI, the team at Scoring, and already using data from Gravity, but increasingly over the year, we're going to be looking at bringing to help combine subnets and do bigger things than any subnet could do alone. So we're really excited for this. It's not easy, but it's been a mission for us, moving as much of it as we can over months, and we're going to be doing more of that moving forward. So look, I think Liam's going to ship everything to production, so you can in. Fuck, I hope it works, but thanks, guys. That was it.
Let's go, guys. Thank you.
Thank you very much, Fox and Stefan. Fantastic. Wow, we should have really done four different Macrocosmos novelty search advertisements.
It's always a little bit of a high octane thriller because we've got so much to get through, but we're going to be on with sharing a lot more.
Miraculously, you ended exactly at 5 p.m. On my time, so right on the dot. Well done.
Thank you.
Congratulations. Wow, so much there. We could go into a lot. Definitely there with folding going to mainframe. That's super exciting. And then having Apex finally have a front end. Screw you, fish. And looking like one of the best front ends on bittensor. Guys, I love what you've done. You've moved a little bit away from you've toned down the neon purple, Will.
Yeah, I mean, I want to give an absolutely colossal shout out to the team at Macrocosmos. People have not slept. People have been absolutely sprinting around. We reshipped the production version like 10 minutes ago because it like completely collapsed. So it's not been easy, guys. I'm really, really, really.
We love you, Macrocosmos.
But yeah, I guess any more questions, guys? I've been involved in the chat to keep my cortisol low.
Let's get people up on stage. Does anybody want to come up and ask questions to the fabulous team at Macrocosmos? Raise your hand and feel free to come up. Easy trades as usual. We got Matt coming up.
Just a quick question for y'all. Do you have any numbers on the amount of or the way the miners are scraping the data versus using traditional scraping methods and then using the API?
So we actually think subnet 13 has really, really good unit economics because you can scrape once, use many times as scales. And from our understanding, like there's a few subnets that mandate use of the I think the Twitter Pro APIs and other things, and we think the guys have just built some really, really crazy custom crawlers that we know. So our understanding is like they do it very economically. I would for the miners, but like they have some really, really impressive going, and subnet 13 is hype. And those guys keep raising the bar. So really, like none of Gravity would have been possible on 13. They're out of this world.
Will, what's the plan for integration with the subnet alpha?
What do you mean? Sorry.
How do you intend to integrate the products here with the subnet alpha token for each of your subnets? Like, what is your dTAO strategy? People are probably interested to hear about that.
So I think we're still working on the specifics of that. Like, there's a big difference in credit systems between a pre-training model and what we expect to use as a credit system that will map back to the subnet for alpha. So we're working on that right now. There's maturity, but we effectively think we'll do some sort of like freemium layer. That's what you can try it, but then you start to pay on a credit basis to use all the different functionalities, scrape data. And for us, what we're is a unified pricing point. Like I think for a lot of people who want lots and lots of different subnets, they don't want to pay for 15 things. So for Macrocosmos, there'll probably be a sort of a pricing tier, and then you get credits within each subnet. And then we'll map the usage back to each system.
I think to add to that as well, something we're looking at right now, people that hold alpha tokens will have, say, credit boost. So this is a reason for people to actually hold the token on our subnets so that they can get more utilization on the platform. So it sort of keeps things in.
Right. So when it comes to, say, Dataverse, having that extra bandwidth will mean that you can scrape faster and use that data for whatever you want, if you maybe even sell it onward.
Yeah, exactly. Like, and you know, we're working out what, like, we're typical, what's valuable, like how much people are going to use this. Like, if you think that like for Twitter pricing, it's $5,000 for 1 million rows, we don't really want to just be a cheap service. We'd rather give you $5,000 and you get 1 million rows of Twitter. And hopefully then if there are, you know, if it's politics, for an example, lots of people are going to be scraping that. We can scrape once, use many, and get some unit economics. So we think actually like 13 scales really well on unit economics. The more users, like actually like usage doesn't scale with, like the more people who use it, the costs will stay relatively fixed. So there's an asymmetry in buy pressure longer term.
Yeah, I was gonna say, Const like sort of stole my question because I was gonna ask about alpha tokens and dTAO. It's like, you know, as a validator, as a staker, one of the things I've been thinking about with alpha tokens is, you know, where does that utility come from and kind of where's that demand being driven from long term from the alpha tokens. Obviously, the first week it's been seemingly like very positive, and you know, kind of curious how you guys are thinking about subnets and alpha tokens and how you drive that utility. Like, is it just from the value of the service that each subnet provides, or are you looking at it in other ways, or potentially, you know, rewarding your users by giving them alpha tokens? Will alpha tokens be the main currency for using the services in each subnet, or will people be able to pay in like other forms as well?
Yeah, I mean, I think like, you know, the Rayon team have done great stuff with the straight to alpha buys. We're hoping to be able to dominate much of dTAO ecosystem. We will have like traditional Stripe payment rails, crypto. Like, you know, that's sort of one of the things, you know, we want to be Web 2 friendly. That's a big part of what we want to do as a business. We want to legitimize as much of these things as we can do long term. And, you know, make these things accessible. And, you know, if you don't want to touch crypto, you don't need to, but we'll be keen to see that come back. So, yeah, I think we're still seeing it as an emerging market.
Yeah, it makes sense. It's kind of like the Wild West right now. There's a lot to still figure out. But in response to Const's question too, Imstones, we've been doing some mining on Dataverse. So I'm just trying to, you know, as a miner, as you know, we're also about to launch a validator as well. One of the things that I'm trying to strategically think about is finding the subnets that have, you know, the least amount of sell pressure, with teams that are committed, subnet owners that are going to hold the alpha token, miners and validators that are incentivized to hold that alpha token. That, you know, creates a positive flywheel, right, of more alpha outstanding, which, you know, leads to higher alpha price, which leads to higher emissions, which leads to just you know, a healthy subnet ecosystem. So
Yeah, definitely. And I think for me, like, there's a balance here. If you think if this was a Series A startup problem on a so for us, there's a balance between like the immediate versus long-term rewards. And I'm really keen to hear the thoughts on this. There's a huge appetite for buybacks, which in the short term are amazing. We also want to be able to invest to build this thing scale, you know, as much as we can. So I think it's a really big question for the ecosystem about how do we make sure we stay in this growth mode. And, you know, the beautiful nature of bittensor is it funds you to grow. And like, we want to make sure that we can grow the pie on these subnets, just, you know, sort of creating flywheels and some sort of effects that, you know, we think it's like, there's a problem, I think, if everything just back, like we can't fund teams to grow and build on this protocol. So you know, on the
Yeah, no, I think that makes a lot of sense. You know, for miners, it's a little different from subnet owners, right? Because like subnet owners, if they have external revenue from, you know, the data or the service that the miners are kind of providing to the subnet owners, then they have external revenue, then they don't really might not have the same need to sell their alpha tokens for tau to kind of cover expenses. Whereas miners, if we're only generating alpha, there is some inherent sell pressure that kind of needs to happen to just cover our baseline operating costs. So there's kind of, yeah, just things I've been trying to think about, and like how different subnets can like incentivize miners to hold the alpha token more. And
would love to work with you on that, Matt. Like, I think it's a new world, it's the wild west. We're keen to work out, like, you know, you guys are a part of Microcosmos, the work can't live without you guys, and it's something that scales for everyone. So really keen to talk about that.
yeah, absolutely. Well, appreciate everything that you guys have built. You know, I'm a big fan of Macrocosmos, and the amount of work that you guys have done for the bittensor ecosystem has been incredible. Obviously, today was just another example of that. But you know, would be happy to kind of take the conversation offline and talk more about, you know, how we can you know, collaborate from a mining perspective.
Hannah, would you like to jump in here?
Yeah. Thank you. So guys, amazing presentation and really, really nice, the kind of innovation that you're doing, especially in the evolution really of the protein subnet, like a drug design, drug development subnet. Fox, would you mind like bringing a little more information on that? I myself have a background in drug design, drug development, specifically using in silico tools to find new compounds that can be relevant as medicines. So it would be great to understand a little more what's your vision here, and how are you thinking about the integration of like this new shape for Subnet 25, considering how like the pharma market works.
Yeah, the audio was a little imperfect there, but I'll run with my understanding of the question, Penna. I think the competitive edge that we have by building things like protein folding subnets and bittensor, we have a few things that are very much in our favor. So the way that trials run, from my knowledge, is first of all, you require a lot of experiments. So it takes a lot of time to rerun the in silico. That, of course, an opportunity for parallelism because of the design of subnets, the fact you have and take up multiple jobs, and we can see them to run slightly different simulations. So there's definitely a speed advantage. Accuracy is a really big part of it as well. I mean, AlphaFold made the headlines. It's an amazing AI innovation. However, it's the way that it works is it's basically going to take an initial state, so or you know, just the specification of the protein, and then it's just going to output the final answer, and that does not really inspection. A lot of researchers need to understand what the trajectory was that took it from its initial state to a final state. Similar with docking as well, you want to understand all of the docking sites on the surface of the protein, not just the best one, but actually understanding, like, are there any areas that you really, really want to bind to? Because that will be detrimental to the function of the protein. And so what we think that we can do that is not available out there is give researchers the ability to run the simulation forward, lots of trials, lots of variables. At any point during those trials, we can take a checkpoint. We can measure the docking behavioristic, the behavior, the characteristic in intermediate states. Of course, the trajectory of a protein from its starting configuration to final configuration, very complex. There may be sort of a global minimum, but in many cases, there's lots of local minima, and they can be very long-lived, they can be very stable in biological matter. And so actually, watching the protein fold in all of these different ways gives you a lot more insight in, you know, again, opportunity and also risk introducing these proteins into the body at all. So we've kind of got scale, we've got speed on our side, we've got accuracy. Customizability is something that, of course, we can give to users. We can allow them to constrain or In terms of the market opportunity, I think there's a few tiers. Right now, we're more focused on getting researchers to critique the design, to help us realign it so it's really useful for them. Government grants are also something that makes a lot of sense from the beginning. But moving further forward, like biotech startups, we're already starting conversations with biotech startups. And eventually, of course, when we really prove this, pharmaceutical companies with, the biggest wallets, guys, to be honest. If we can show them they can do 1,000 times trials at, much faster than they'd be able to without a lot, yet fully auditable, explainable results, is something that would be very valuable based on our market research. So that's really the reason that we've gone from pure protein folding to market. And as Will mentioned, the idea of mainframe is extending the scope even further. We've built a lot of general machinery for decentralized science research, components that we've developed, very generalizable. And so it makes sense for us to make the scope of what we're doing as valuable to bittensor and, of course, people that want to use products.
Yeah, no, that is amazing. I think it makes total sense. And it's really, really nice to see this kind of approach. It's very clear, presenting a path for this site to really happen in a decentralized way. And well, it would be great if we could take like a conversation offline and discuss potential synergies.
I would be really interested in that. Please DM me. Talk.
Amazing. Thank you.
Cheers.
Okay, guys, thank you. It's over the hour now. Stefan, Will, congratulations, and to the rest of the Macrocosmos team, fantastic work. Let's end it here. Thanks, everyone.
Thanks, guys.
Thanks
for
again.
having us.
Thanks again, Constant. Thank you again to Macro. Wonderful.
Everyone, have a good night.
Thank you.